Okay, so let's go ahead and prove the triple angle identity for sine today. Okay, so the claim is that the sine of 3 alpha, triple angle, is equal to 3 sine alpha minus 4 sine cubed alpha. Okay, let's prove this. Okay, so we've got the sine of triple alpha. I know right away I can write this as the sine of alpha plus 2 alpha. Okay. And then I'm going to go ahead and use the sine of a sum expansion. I'm going to put that in the box right up here. I have proven this in another video. But if you have the sine of a plus b, that's equal to the sine of a times the cosine of b plus the sine of b times the cosine of a. Okay. Let's get that in the box there. Okay. So good. Using this formula, for which I have a proof in another video, if you so desire to see that, we're going to have sine of alpha, cosine of 2 alpha, plus sine of 2 alpha, cosine of alpha. Okay? Very good. Now, we've proven in another video that cosine of 2 alpha is equal to cosine squared alpha minus sine squared alpha. And we've proven in that same other video that the sine of 2 alpha is equal to 2 sine alpha cosine alpha. So I'm going to go ahead and use those identities here. And let's go ahead and establish that we're using them. So sine of 2 alpha equals 2 sine alpha cosine alpha. All right, so that we are going to use. And we're also going to use, of course, cosine of 2 alpha is equal to cosine squared alpha minus sine squared alpha. Okay, very good. Now, going ahead and using these identities, we're going to have sine of alpha times cosine squared alpha minus sine squared alpha. Okay, plus 2 sine alpha cosine alpha, but then there's a cosine alpha here. Okay. All right, let's go ahead and expand in simplifying. So expanding, we're going to have sine alpha cosine squared alpha minus sine cubed alpha, okay, plus 2 sine alpha cosine squared alpha. Okay. Okay. Well, we got a minus 4 sine cubed alpha here, and we got a sine cubed, and we want to then exchange these, the cosine squared alpha and this cosine squared alpha with 1 minus sine squared alpha. So I will also be using, of course, this Pythagorean identity, sine squared alpha plus cosine squared alpha is equal to 1. Okay, so that's another identity I'm going to be using here. Okay, so this is going to give me sine alpha times the quantity, okay, by this famous Pythagorean identity, 1 minus sine squared alpha, okay, minus sine cubed alpha, okay, plus 2 sine alpha, okay, and then cosine squared alpha is again 1 minus sine squared alpha. Okay. Let's maybe zoom out a step. There we go. Okay. Okay, checking that. Yeah, that looks good. Let's go ahead and use the distributive property. Okay, so it's going to give us sine alpha, okay, minus sine cubed alpha, okay, minus sine cubed alpha again, okay, plus 2 sine alpha, and then minus 2 sine cubed alpha there. Okay, and we are done. Sine alpha plus 2 sine alpha is 3 sine alpha. Negative sine cubed alpha minus sine cubed alpha minus 2 sine cubed alpha is minus 4 sine cubed alpha. There we go. Not so bad. Okay. Hopefully that helps. Now you can understand not only how the triple angle identity for sine works, but why it works. Always appreciate your questions, comments, and concerns, and recommendations for future content. Have a great rest of your day, and we will see you in the next video.